So first of all, we are doing what's new in AI, usually from the point of view practical applications. So it is not blah blah, not, how do you say, celebrity news, but it is practical applications. That's where they are. But one of the previous times you guys asked, you said, give us a challenge, give us something to do. And initially, I gave you the virtual machine. That was no fun. You know, people have virtual machines, no big deal. So instead, I'll give you a challenge, a little bit from math to refresh our brains. And that is pertinent because I'll talk about what AI now does with math, and that's very interesting because it's extremely fresh. It's really a few days old and groundbreaking, you can say that. Then I will show you one of the new courses by Andrew, and in general, I will explain why it is an important thing. And then there will be quite a few unanswered questions. So here are the four subjects, and today I don't have an answer to all of them. No. I have partial answers, but not all of them. So, number one, prove to me that square root of 2 is not a rational number. Okay. There you are. Now, what is a rational number? Rational number is anything like 1, 2, 3, 4. These are all rational numbers. They are even better than this. They are natural numbers, okay? Now, 2/3 is a rational number. It's a ratio between two numbers. Okay, so far so good. But square root of 2 is not a rational number in the sense that there are no two integers that if you divide them will be square root of 2. So let's say P over Q. You cannot find such P and Q. Okay, I'll give you a minute or two. If you want to explain why not, I'll be happy to give you the mic. Meanwhile, I will start with my proof. Why is that important? Well, first of all, that helps your brain not to grow stale, but it is important because it was quite a big puzzle for, I think it was Aristotle. When he discovered that, he was flabbergasted. You know, the world was simple. The world was based on integer numbers. So integer numbers came from God, everything else was human invention. That was the idea. But when he discovered that that was a true fact, that you couldn't have two numbers. In other words, let's say square root of 2 is P over Q, which would mean that Q itself, the 2 itself would be P squared. I'll give you the notation that the head like this. P squared divided by Q squared. Okay. That's what it would mean, that you have two integer numbers that if you take, I didn't write it completely perfectly well, I'll add a number 2 at the end. There you are. And you don't have those P and Q. So let me give you first an idea, but what I really will show is a beautiful geometrical proof, which I almost got complete, and maybe you can help me with that at the end. Okay. Ah, Jason, you got the proof. You're saying then what you would have is that. Now, Jason, do you want to explain it? Can I give you the mic and you will do it? Let me at least suggest. Okay, wonderful. What could be better? Awesome. So here's Jason. Okay, you're now a panelist. That means you should be able to talk. Okay.
Hey, thank you for the opportunity. Can you hear me?
Yeah, wonderful. Perfect. Excellent.
Yeah, I actually just joined in and I thought this is a very interesting topic. Yeah, I just share with you my thoughts. May
Mm-hmm.
not be correct, but based on the formula, the p square equals to 2 times q square. So that
Yes,
means,
we agree so far. Yes.
yeah, that means the p square is even.
Mm-hmm.
And if the p square is even, then the p itself must also be even.
Mm-hmm.
Because the square of an odd number is still odd,
It's odd, and the square of
right?
an even number is even. Yes.
Yeah. So in that case, so so p square is even, and we do the reasoning. So p itself must be even. Then p can be written as 2 times something. Say
Mm-hmm.
p
Mm-hmm.
equals to 2 times x, and
Yes.
then we plug in p equals to 2x into the original formula that p
Mm-hmm.
square equals to 2q
Mm-hmm.
square. And then if you do the derivation, we'll get something like q square equals to 2 times x square.
Mm-hmm.
So that means the q square also is even.
Also even. Yes,
And also
agree.
q, that means q is also even.
Mm-hmm.
So now we see p is even, q is even, and because both of them are even, and that means they have a common factor of 2, and
Mm-hmm.
which contradicts with our original assumption that the p divided by q was in the lowest simplified term.
Uh-huh.
So
Okay.
that's that kind of reasoning. Yeah.
That's where I was going to say now polish it a little bit and say that let us say we found the smallest P and Q that could do that for you. Because that's one of the proof steps in the proof that you need. Let's say P and Q are the smallest possible numbers for which they would be a square root of P and Q. Would you agree?
Yeah. Yeah.
Okay, well, wonderful. So what I will show you is here a geometrical proof of the same thing. Very beautiful and very modern. So let us say this is your P and this is a Q, and the ratio of them is 2. So P squared is a square like that, and Q is a square like that, and I will prove to you it's not possible. When P and Q are integer numbers, because again, we start with the same assumption that P and Q are the smallest possible numbers that will give you this P squared equals 2 times Q squared. Now, if you take that same square and move it here, you see, it's the same, move it here, and then what you do is you take the yellow squares and put them into the blue ones. Okay, you do this and then take the second one and put it here. So far looks reasonable. Okay, and now you will observe that these are the same squares. I didn't change them. They intersect, overlap here. Well, it turns out that that orange is the same area as these two. And then you have the smaller than this numbers. So we started by saying that P and Q are the smallest numbers that will give you this picture. Well, I'll find you the smaller than that right here, because now this will serve as that one, and these two will serve as that one. Now, honestly, I don't quite get one place. It looks reasonable, but the guy who is a very nice mathematician, the way he explains it, he says the orange central square must be exactly balanced by the two small uncovered blue squares. So I don't get what that word balanced means. So we almost got the proof, not completely. If anybody wants to help and explain why that proof is perfect, then great. If not, let's do this. Let's go back, and here we put the next session, and it will be 23rd. And explain the geometrical proof. Okay, that's kind of a warm-up. Warm-up for something better. So I'm going to the next step. Now, Paul Erdős is a Hungarian mathematician, one of the geniuses of this world. Maybe I can find a picture. There you are. And Erdos, pronounced like this, and that's him. So that very interesting person used to work like this. He would travel around the world, find a mathematician willing to work with him, would work with him for 18 hours or as long as it takes. And when the other guy is completely exhausted, Paul Erdős goes on. So Paul Erdős had a private joke, and private joke was that he called God supreme fascist. All of that you can find it in a book about Paul Erdős. And he took it very personally. He would say, "Where did the supreme fascist hide my glasses?" You see, he has very, very pronounced glasses. But that's not what I'm going to talk about. What I'm going to talk about, that Paul, you can imagine, he left quite an inheritance in terms of problems. So he created about 700 Paul Erdős problems. And recently, AI solved one of them. Now, I'll show you where, how, and what, and why it is important. Now, I saw some hand raised, so let me go there and see who raised the hand and what did they want to say. Any questions so far? Okay, so going to talk about exactly that. Now, that talk comes from Terence Tao. Who is Terence Tao? He is the smartest person in the world as of today. No joke. His IQ is higher than anybody else's in the world. He is a mathematician. He received the famous Field Prize. Now, the story goes that the Nobel Prize, that Mr. Nobel, a mathematician, stole his wife. And therefore, Nobel said everybody will get the prize, $1 million, but mathematicians are excluded. So the mathematicians invented their own prize called Field, and Terence Tao is one of the recent recipients of that prize. And here he talks about how AI solved problems. Now, which problem? Right here. Number 728. Now, if you want to go, Terence is very nice. He shows you what the problems are. And I'll tell you, they are not easy. Not even easy to understand, of course, much less to talk about the proof. But it's something like that. We're talking about only mathematicians could be curious about how many solutions are there to that equation. It's talking about big numbers, and it's talking about are they divisible by something or not. So I'm closing that for now and continuing with Terence Tao, who, by the way, works with the OpenAI. He is probably the official mathematician on the OpenAI team. and he works on their projects, essentially trying to say that AI is as smart, very close to humans, and that would be what is called singularity, the point where AI becomes as smart as human, which again leads us to the very important question. Well, how smart are humans, or how are they different from AI? Let's say AI now can talk and solve problem. What is the difference between me and AI? That is a question that we are not going to try to answer today, not even try. Let's continue. What happened is that they took one of the Erdos's problem, which I showed you, and AI solved it, came up with a solution. Of course, tools were involved. Which tools? There is a model called Aristotle. There is such a model. There is also a language, how to formulate a mathematical theorem, and that language is compilable, so it's a computer language on how to formulate and prove mathematical theorems, but it allows you to formulate things that are very complex and precisely formulated in your um, in your brain and also in the computer. So solved. Now, what Terence is going to say that's not the most interesting thing that he wants to talk about. He talks about how these four mathematicians, Erdos first, Graham Rusa, and Strauss, how they studied a certain polynomial coefficients. Now, what are polynomial coefficients? That at least is easy. Okay, we can go to chat and just look it up real quick because I was just doing it myself. So polynomial coefficients are written like that, but what's important about them, they appear in many places in probabilities. You might have seen them. I wanted some examples. Yeah, these are good examples of polynomial coefficient. Now that everybody probably saw. And that's why I call polynomial. That's the first degree, second, third, fourth, and so on. Okay, now we know what polynomial coefficients are, okay, and we know what they studied, and they come up with an interesting question, and AI now resolved that. That happened just a week ago. And then Terence says that, I'll tell you something, we are close to singularity. Because if ChatGPT was able to work with that, and a human was involved. In fact, if you search on Google, it will summarize that Terence was involved. You also, if you want some critique, you will say that everybody talks about how smart AI is, and that everybody is Terence now. But why not? Even if it is only one person. Okay, so it seems like we don't even understand what they're talking about, but we see that a third participant is Aristotle, so it comes in philosophy. It mentions all of them, Aristotle as a model, and Lean as a language, and AI produced proof. And the most important statement that Terence is making here is that we are nearing the singularity point. All right, that's where we are. Any comment? I see some comments on that. Can you share the link to the page? Okay, that's easy. That is that page. So I'm giving you that one link. That's the only thing that you need. Shravan, here is the link. From that link, which should open for you, from that link, you can go scroll down, and then you will find AI solves one of the Erdos problems. That link opens. I'll show you again. I click on it. Terence Tao. That's Terence Tao talking on maths.don. By the way, I should mention more and more facts. You know, my wife doesn't want me to do too much philosophy and constantly uh, slips in mathematical facts so that I would be distracted. And one of them is that everybody knows there is a place where you look for no, for programming problem. That's Stack Overflow, right? Stack Overflow. And then your reputation is based on Stack Overflow. Well, that everybody knows. Perhaps not everybody knows that there is also a Math Overflow. Overflow. No, Math Overflow. That's where I want to go. Okay, that's Math Overflow. That's the same as Stack Overflow, but for geeky geeks, more than that. And I was listening to a lecture about that, and that's why it came up. I'm looking for the top guy because he was, being the top guy here, he was talking about exactly that. But that I didn't prepare and I didn't plan. Your question was, where's the link? That's the link. Yeah. And I think it is all very, very cool. But now we need to go back to practical applications because it's all about AI today. And we talked about how to show that square root is not a rational number. You know, the Greeks, they made the religion of many things, and one of them was the numbers. And when they found out the square root of 2 was not rational and proved it, even back then they had the proof, they didn't publicize it. Wow, Steven, that's awesome. So give us a link where Terence Tao talks about you giving a problem that is very hard. Can you please? Okay. Unbelievable. Very interesting. So, but practically, we need to program, we need to make a living. So that is the new course. The courses from Andrew Ng, as always. And I confess, I prepared our repo. Yes, here. So if I go there, I will even have it. Yeah, Landing.ai. But I have not even done one lab. I'll talk about that. I'll show you why it's important. But I have not completely done it. But on the other hand, all other things are pretty hard. What I want to do is this. I will stop the share. I will share again with the sound this time. And I will go and let Andrew spend a couple minutes explaining what it does, and then I will chime in with my comment. So here you are. Let's go there.
PDF files and other documents on our laptops, on the web.
There you are.
Welcome to Document.ai, from OCR to agentic doc extraction, built in partnership with Landing.ai, where I'm executive chairman. A lot of data is locked up in PDF files and other documents on our laptops, on the web, and in companies' cloud storage. In this course, you implement document processing pipelines that transform your complex documents into LLM-ready markdown text and extracts information for analysis. You begin by exploring traditional OCR, which only extracts text, and then add techniques to detect document structure and identify visual components, such as tables with complex formatting like merge cells, or charts with captions, or forms with checkboxes. You implement an agentic workflow that combines layout detection with LM-based reasoning. Then you learn to use agentic document extraction, or ADE, a tool designed by Landing.ai that automates this entire workflow for you. I'm delighted the instructors for this course are David Park, who's Senior Director of Apply AI, and Andre Trop, who is Apply AI Engineer. Both have helped many developers build complex document AI systems.
Thanks, Andrew. We're excited to teach this course together.
Sorry to interrupt. We cannot hear the audio.
Do you hear me now?
Yes, it's working.
Okay. Thank you very much for doing this. I mean, I was talking. Okay, so I was saying that what the problem that Andrein solves and his lens in AI is a very important practical problem, because let's say you get a weirdly formatted PDF. So it has tables, and tables carry additional meaning because you have columns, and sometimes in each cell you might have 2 or 3 values. So that is impossible if you don't take their position into account. And that's what Andrew does. I will show you what I do. So his technology solves this problem. I cannot use it because I work for some legal entities that don't allow open technologies to be used. Okay, so in any case, that's very important. I will then show you an example of what I do in my practical work. For that, we'll go right here, and here is a list of a few projects that we're working on. The most interesting is this one. Now, that's a rep tool. Let me tell you what is a rep sheet. Rep sheet is a police, you see, record of arrests and prosecution. That's what it is. And we probably can see an example. You can even write to FBI and they will send you what they have on you. You personally are allowed to ask them what they have on you. I tried it. I paid $18. It didn't work. Nothing came, but it exists. Well, one of the things that I'm working with is exactly that. That's a rep tool. Now, I am not allowed to show you a real rep, but I will show you a Mickey Mouse rep. So open rep tool, okay? And I must have the Mickey Mouse here. Donald Duck, not the Mickey Mouse, sorry. I'm dropping it right into the tool. Now that I'm allowed to do because it's our own invention. It will take a minute to process. What it will do is OCR. There you are. It worked pretty fast. And then we extract all the information. Now, from paper to this structured output, I think that's grandiose. Here is who Donald Duck is, where he lives, what arrests there were. Well, it turns out that it's a dark world, and he lives, you see, in Sacramento. All court problems, nothing, conviction, so he was lucky. But there is more. If I click here, that means I want to know more. It says, oh, I found it here. So you can imagine what kind of intelligence that is not hopeless. It is living on Azure, using the intelligent document analysis OCR by Azure, but then you have to add a lot of stuff. So you can find, why do you think that this happened? Click here, and it will show you. I don't know. No, this. There you are. It will show you where that happened. All right. In other words, it's a practical problem. Andrew solves it with his lens in AI, which I think is good enough for any application other than that kind of too much police overview. And that is pretty much it. So let's do this. Let's continue with Andrew Ng, because let's look at his course and see what is involved, whether you have your own technology
Traditional
or
OCR
no.
systems work by
Okay, so first they explain how you need to do it with the OCI, and it's a basic thing, but they give you a code example. So if you click
They
there,
decide I need to read.
then that appears as a Python notebook right here. Now, when it appears, you naturally want to download it. You hope that this click will do it, but it doesn't do it. Instead, the trick for that specific course is this. You have to click on Open. Then you see the files. Then you go inside of one of them. Right here. And then I think you can even download. That's how you can work with it, and you can get. So practically you can download that. It will not be completely very easy, but you can run a very simple OCR problem using Landing.ai. That's the Andrew Ng that he offhandedly mentioned that he is the director of that. So it is a rare case where it is self-promotion. Usually people come to Andrew and they want to do a course with him. In that case, Andrew comes to himself and he wants to do a course with himself. Now, what else is involved if you want to do, it's called Intelligent Document Processing, IDP. That's the whole area. Well, there is an overview of the technologies that were involved and what open source tools are there, how you then involve agentic document understanding. And as you can see, labs and lectures and labs. So it's a great resource. When you want to use it, you will find it right here. That's where it will be. And let me just go back a little bit. So we do exactly that, hands-on AI technologies. That all is found on Learning Path. If you're interested in, well, how should I learn about that? You click here. You click here and you come to a document that's called AI Education. And first of all, the size. You will see that there are, going down, over 100 different courses. Some of them are already in my repository and some are not. Some from Andrew Ng, some from any other source, and not necessarily all published on deep learning. So if you know, you just search which area interests you. If you only start today, then that is the complete list, what you can find on here on I don't understand why that picture comes up. It should be about everything. But then you can start with Andrew Ng's own course, which he promotes, and I think for a good reason. All kinds of generative AI for everyone. If I make a mistake, then my mistake usually is not using AI enough. When I am faced with the problem, then the easiest, well, ask that problem from AI. If nobody who is awake is around, then AI is always around. And that is, I think, the last thing that I wanted to say, that there are a lot to learn. They don't overlap. What I want to say is that all these courses are about different things. You will not believe me, but yes, it is more than 100 courses and they're all different. If there is an update, usually I just update it and even merge. So it's more or less honest number. All right, now I see some comments. Let me do this. Let me go to the comments and let me talk. All comments were my fault. So Steven Steven, you got the attention of Terence Tower, and we definitely need to review it, and we'll look at it next time. So I'm preparing this. Here you are, and that's for 23rd. So okay, we recorded that. Okay, usually what then I do is this. I become invisible, I mute myself, and I ask you, so any suggestions or any questions. Let me do that. Okay, but if no, well, you gave me good ideas. You gave me enough questions and suggestions as we went. So I want to wish everybody a great weekend and a good year to go. Let's check. Anything? Can you send the link to the document? Yeah, I'll be very happy to. So back to share. And that is the document, okay? So I'm giving you that link. All right. I'm giving it to you on the chat here. Exactly. You're getting to that. And here's the link to the document. Wonderful. And thank you very much because you force me to learn every week. I have to know what's last, what's new. All right. Okay. Shravan, that's your first call. Good question. Today, there was a little bit more academic than ever before. Yes, I agree. But academic is there to stimulate your brain. The practical things, they come at the bottom. So it was that course. Usually there is more practical things. Yeah, I agree. I can understand that. So I'll keep a good balance. No, I understand, but I heard a very little disappointment. Okay, well, it's mostly practical, but now it's becoming a little bit more, if not academic, then I would say challenging. So I'm wishing everybody a great week and a good year ahead.